This is going to be a very quick introduction to the concept of friction. And friction gets progressively more difficult as we change the angle of slopes and things like that, but this is the simple version to start with. So very, very basic friction example is, let's say for instance, a 100 kilo box sitting on a surface. That surface and the box in between there have a certain amount of friction. The roughness between the surfaces give you a friction, and that friction is measured as a coefficient of how hard it is to push this box or pull this box across the floor based on its weight. So the ratio between its weight and how hard it is to pull is the coefficient of friction. And you can see this in the formula over here. Friction coefficient is equal to the frictional force divided by the weight, or the normal reaction. The normal reaction is a reaction to the weight force of an object, and it's always perpendicular to the surface, not to the box itself, but to the surface of an object. So if we had an incline, which we'll talk about later, and the weight of the box was here, in this example the normal reaction would not equal the weight, because the weight would be acting straight down, whereas the reaction force is perpendicular, or the reaction force here is perpendicular to the surface. So it's important that you understand that the reaction force is a force perpendicular to the surface, and the frictional force is always horizontal to the surface, or parallel to the surface. So over here, if we're trying to pull this object P across that way, the frictional force will act against that pulling. So no matter which way you try and pull an object, friction works against you, and so it'll work in a horizontal or parallel direction to the surface. So reaction forces are perpendicular to surface, frictional forces are parallel to surfaces. Now let's look at the example that we've got over here with a flat surface and a box. This means that we can easily calculate how hard is it going to pull this 100 kilo box if we know the frictional coefficient. So given a coefficient, let's say 0.25 of friction between this box and the surface, we can then calculate, well, if the box is 100 kilos, so the weight is equal to, and I'm just going to use 10 instead of 9.8, is 1,000 newtons, then we know that to overcome the frictional force we will need to include this formula over here. So the coefficient of friction says that the weight, the normal reaction in this case, is equal to the weight. So we know that the frictional force we need to overcome is equal to our reaction force divided by a coefficient of friction. I've just taken this formula and I've moved it around. What I've done there is I've multiplied both sides by Rn. And so by doing that, I've actually seen I've made a mistake. It's not the reaction force divided by, it's the reaction force times by the coefficient of friction. So if I use that as my basis, then I know that my reaction force is 1,000 newtons. My coefficient of friction is 0.25, and so 250 newtons of force would be required to overcome friction. So the force P here I need to overcome friction is 250 newtons, which is the smallest amount of force I'd need to start moving this box. I hope that helps you, and I'll move on to a slightly more complicated question next.